Alright everybody, time for another video. This time, taking what we learned, or hopefully learned, from the investigation, and doing some problems that use the information from that activity. So we will be talking about circles exclusively in this video. We'll be talking about area and circumference of circles. Part of area and circumference is those ideas of sectors and arc lengths. So we're going to be covering those as well. Again, remember you're going to need a calculator because we will be using pi. If your calculator does not have pi, make sure that you are using 3.14 instead, as I have had to do in the previous examples. So starting out, just putting down the formulas again. Both of these formulas can use the radius. So if we want to know what the area of a circle is, we just use the formula pi r squared. If we want to use the circumference, we use 2 times pi times r. Easiest way to do it. Now, in this first example, these are a few more complicated examples than just finding the area. If we were asked to find the circumference, which is 2 pi r, of a circle with an area of 34, remember area is pi r squared, what we could do is we could use the area formula to find the radius, then plug the radius in to find the circumference. If we know the area is 34, we can set up 34 equals pi r squared. So first thing we would do is divide both sides by pi. Again, my calculator, I'm going to divide both sides by 3.14. So I have 34 divided by 3.14, and that gives me that r squared is about equal to 10.83. So what I need to do then is I need the square root of that number, 10.83. And you should be getting that the radius is something right around 3.29. We're going to then take this radius and we're going to plug it into the circumference equation. So we'll have 2 pi times 3.29. And if we take that times 2 times, okay, you should find that the circumference is about 20.66 units on circumference because it is a length going around the circle. Should just be plain old centimeters. So there's that one. Calculate the approximate area of the shaded region. Didn't show up very well on here, so I'll tell you the shaded region is this combined with this. These entire regions, basically everything except for the circles. We're told that the diameter of the large circle is 28, and that the two smaller circles are congruent to each other. So if the diameter of the large circle is 28, that means that each of these halves here are 14. What we can do to solve this problem is if we can find the area of the large circle and we subtract 2 times the area of one of the small ones, we'll have what we need. Well, the area of the large circle
just a quick reminder to our AP teachers,
is going to be pi, and the radius of the large circle is 14, so it's going to be pi times 14 squared, and then we'll subtract 2 times, and the area of one of those small circles, well, if the diameter of the small circle, which is half of the diameter of the big circle, is 14, that means that the radius of one of the small circles is 7. So we're going to do 14 squared times pi minus 2 times pi times 7 squared. So let's do these calculations and then do the subtraction second. If we want pi times 14 squared, that's 3.14 times 14 squared. Should be getting something around 615.44 for that. And then we're going to want to do 2 times 3.14 times 7 squared. And that gives us 307.72. If we do 615.44 minus 307.72, we will discover that the area left over is 307.72 units on this one. We're dealing with meters, so area is going to be meters squared. Okay. So now we get into the new part for us. What we want now is the area of a sector. And what you probably discovered in the investigation was that basically what you're going to set up is a fraction. What part of the circle are you looking at? Let's call this theta, and let's say we wanted to know this area in here. Well, what we would do then is we would take, if we want to put it into words, we would say angle over 360 times full area of circle. Putting into the math symbols, that would mean in this case theta over 360 times pi r squared. That would be our area of our sector. So if we wanted to know, for example, in this one, the area of this sector, this piece of the pie basically, in this case our theta is 65 degrees. So we'll have 65 over 360 times pi. Radius, they tell us, is 4, so it'll be pi times 4 squared. I would recommend figuring out what 60 out of 360 is as a decimal first. So 60 divided by 360. And you're going to get a decimal for that, and I would go right from there to starting to multiply. Decimal that you should get is about 0.18, so you're going to take that, and you're going to multiply by 3.14 times 4 squared. And that'll give us the area of the sector being about 9.07 inches squared. That's good. In this problem, we're kind of going backwards. We're told that this whole thing here, the area of that, is about 31.47 meters squared. Now, how big is that section? Well, we're told that this here is 51 degrees, and the whole circle has 360. So that means that the part that we have left over is 360 minus 51, which means that this part is 309 degrees. So we're going to kind of work backwards like we did in one of the previous examples. We know the area of the sector is 31.47, and that's going to be equal to 309 over 360 times pi r squared. That's the area of the sector. Let's figure out what 309 over 360 is. 309 divided by 360. So now, that makes it a little simpler to look at. We know that we have 0.858 or so times pi r squared. If we multiply 0.858 times 3.14, we're going to get about 2.695 r squared equals 31.47. I'm doing these steps first because I want us to have a really simple situation before we have to deal with r squared. So all I've done so far is I've turned this into a decimal, and then I multiplied these two together to get this number. So next, we're going to want to divide both sides by that 2.695. So 31.47 divided by 2.695. So we find out that the radius squared is about 11.677. To find the radius itself, we will take the square root of that. And when you take the square root of 11.677, we find out that the radius is about equal to 3.417. To get the diameter, we're going to double that, because that's what this question is asking for in the end, the diameter, not the radius. and the radius is half of that. So that means that the diameter is 6.834. We do have units this time. We have meters, and diameter is just a length, so it's just going to have the unit of meters. So there it is. That is a tough problem as far as these problems go. I think that you're all up to it. You may need to rewatch that one again, or you may need to ask a few questions about it. That one's tricky. Okay, almost done. One more thing, 2 more examples. So here we have the arc length. An arc length is basically the same thing as sector is, but dealing more with circumference. So arc length is going to tell us how long this type of segment is. Well, we have an angle here that we know. And the way we calculate arc length is going to be very similar. We're going to have our angle over 360, but instead of multiplying by the area formula this time, we're going to multiply by the circumference. So, in this example here, find the length of arc AB. We know that the angle is 60 degrees, so we're going to have 60 over 360 times 2 times pi times 6, 6 being this radius right here. So we are going to need the calculator again. Again, I would recommend figuring out what 60 divided by 360 is first. You should get about 0.167. So then take that number and multiply by 2 times pi, or 3.14, times 6. And you should be getting a result of approximately 6.28 centimeters. Now this is a length. We're finding AV here. So we just use centimeters. We are not going to use centimeters squared because it's not an area. It's just a length. In this next problem, last one we're going to go through here, we want to find the radius of the circle. And this is another one of those where we're going to kind of have to work backwards. We know that 19.71 is the arc length across from an angle of 55 degrees. That's 55 out of the total 360. And we know that if we wanted the circumference of the circle, the whole thing, we would have 2 pi r. So again, what I'm going to recommend is that we multiply all of these numbers together, figure out what that is, and then it'll be a very simple problem comparatively. So we'll do those calculations. 55 divided by 360 is about 0.153 times 2 times pi. Multiplying all those parts together, we get about 0.959. And we still have to multiply that by the radius. Well, now it's a one-step problem. All we have to do is divide by 9, or 0.959 on both sides, and we'll have the radius of the circle. So 19.71 divided by 0.959 gives us that the radius is approximately equal to 20.553 centimeters. All right, so some pretty intense seeming problems here. Some of them are a little more straightforward. I highly suggest that you ask questions if you are stuck on any of these ideas. But next thing that you should be getting ready for is the quiz coming up. So remember, these videos are here for you to rewatch if you need to. You can also ask questions in class. You can ask questions to people, to classmates. So lots of options. So thank you for watching, and good luck coming up on the quiz.